Week, everyone joining in. So let's just dive into it. Yeah, I always put this slide up as a maybe potential try to have in-person meeting, but anyone knows any sponsors, let me know. No new papers that I know of other than these ones that came out end of last year. But if you know of any from our group that's come out, I should put on this slide, let me know. Just some really brief updates. I know with Al, we've been working on the long COVID case reports. There's a couple of more that he has, so people are interested in helping out with these interesting long COVID cases. He's gotten the proper approvals from his hospital to, end the patient consent to actually work on these case reports. Hopefully, try to figure out what's going on and just discuss about what's happening with these long COVID unique cases. But if anyone's interested in joining, let us know because we're trying to get going through the data now and getting a paper ready hopefully soon. All right, let's just dive into the news part. There was this nice paper that came out in Lancet recently. There's talking about this group had done modeling about the death rates over the U.S. from 2021 June, I think, till there it is, July 2022 or January 2020. Sorry, July 30, 2022. But overall, it just goes over the statistics, and parts of this is a figure from this paper. I guess the most deaths that have happened over this time was in Arizona, as I said, and the least was in Hawaii. So, and they've gone through this paper looking at different stratifications of how you look at the population. So, if people are interested, take a look at that. There was this nice article that came out. It's not really a paper. This is a review paper, but many of you know that I've been talking about no conclusive evidence, but a potential link between like COVID-19 cancer. And this guy, Kashaf Patel, actually is a clinician and is the president of this nonprofit Cancer and Associates patient group. But in this nice article here, he talks about the uptake in cancer patients and also talking with different clinicians going over. And this article then talks about like what's been known. There's the type then pinpoint this review article that came out last year, 2022, January 2022, talking about potential links between COVID-19 and cancer. And I have some indirect data that could potentially show this also, but it's nothing conclusive, right? But what's interesting is that he was saying in this article that there seems to be between the patient populations they're looking at 2 to 3 times higher basically cancer incidence and progression happening with some rare cancers that shouldn't happen until the 65 years or older, but then all of a sudden we're seeing a big rise in the past year, between younger age populations. And then they go on to talk about different more as he says here, this quote, like breast cancer is more common cancers and malignancies. And overall, the article ends well. There's a common denominator of these studies that they looked at, and people even talking to clinicians that, there might be a link, but of course, it needs to be more studies to actually show this link. And we might not know for years if this happens, but we should probably at least try to figure it out if this is a real thing or if it's just something that is a coincidence. I think it's a good approach to try to find research money to actually investigate this.
Action.
Yep. Go ahead, Bill.
Isn't our essential model that these relate back to mitochondrial dysfunction is a better research route to follow?
Yeah, mitochondrial dysfunction and cancers is a big thing too, but there's a lot of different factors involved. So
sure.
Yeah, a lot of it's, a lot of the things they talk about in here is related to inflammation. We know a lot of inflammatory factors happen and consistently would, happen. Of course, mitochondrial dysfunction is a big player in cancer too, yeah.
If we had good mitochondrial functioning, would these other matters come into play as strongly?
Depends on the mitochondrial function and disorder, which could or could not lead to cancer. So it just depends on all the different key factors. But the point is, we have to do more studies, and this is, I think, one area. I think this guy agrees with me that this is one area that is understudied, and maybe we should look into whether it's true or not. Well, studies will reveal that, but there's a lack of studies on this now. But it's interesting that his article talks all about the increase in different type of cancers they've been observing in the clinic in the past year. since March 2020. So this is an interesting paper. I'm going to go over a few of the. Oh, I'm not. Yeah, this one's an interesting paper, which I won't go through the figures, but you should probably take a look at this. But it's an interesting paper that this came out a week ago. I was talking about the immune relationship in the CBS article here. Was talking about this paper, but it's about the immune about how the SARS-CoV-2 will impact the CD8 or the T cell population, the CD8 positive cells. So what's interesting is that they talk about that CD8 positive, CD4 positive cells, after SARS-CoV-2 infection, seems to have a long-lasting effect to basically, in a nutshell, diminish the capacity of activity and response to diseases, and the ability to actually fight that disease. Right, the CD4 and CD8 positive cells are key for our immune cells to fight off different infections and diseases. What was interesting is that they also, when they compared vaccinated with the Pfizer or not, that if you were exposed to SARS-CoV-2 previously before your vaccine, you were vaccinated, your T cell response to the vaccination, as they put in the highlights here, was actually reduced. So that means if someone was infected previously before vaccinated, the vaccine efficacy is probably reduced a little bit according to their study here. So it was it's a nice study. Maybe I don't know if people are here from the immune and inflammation group, but this could be something that you might want to consider to include discussion points in the paper.
One thing to mention about T cells is the propensity with long COVID for T cell dysregulation.
Mm-hmm.
We actually helped Adaptive Biotech bring the COVID T cell test to market, filled their cohort, and I received the first T cell test in the country. And I tested negative after a confirmed case, 6 months after a confirmed case, which made the rollout of that, the media rollout a little bit complicated, but
right.
Just to note.
Yeah, no, this they don't talk about long COVID here, but this would indicate that, if there's a long-lasting impact on your T cells from the infection, yeah, that could definitely be a contributor in long COVID.
Yeah, we thought at the time that it was going to be a way of, getting around the people who were not seroconverting and to figure out who had actually had COVID and who hadn't, because you can get into a long COVID care center. So the practical policy sort of manifestations were real, but, it ended up being that they pulled the product a few months ago.
Yeah. No, it makes sense based on what people are starting to see. Early on they thought maybe the T cells were retain the memory, of.
Yeah, I conducted many a T cell webinar at the time. Don't.
Yeah. But these studies and
there's
some other ones. Yeah. There's these studies, some other studies coming out that's saying that our initial thoughts was wrong. There's a lot of things with this virus we find that things are not according to plan.
Heads were spinning when my results came in negative. You can imagine.
Yeah. Well, now 2 years later, you know why? Maybe.
Yeah. Exactly.
Yeah.
Go
ahead, Kevin.
If I can, can just interrupt for a second. Clarification. So they compared it to what vaccinations or
just the Pfizer one? They looked at only the Pfizer vaccine.
Okay.
Before and after exposure to the vaccine.
Okay. Thanks.
Yeah. They don't look at Moderna or any other ones, but I guess the assumption would be maybe the other vaccines should maybe do the same. I don't know.
They could look at routes too.
Right.
Oral versus IM and
sure.
Bivalent versus non-bivalent.
There was they didn't talk about bivalent at all. Yeah, exactly.
Yeah, I'd want to know for Novavax is what I would want to know the difference on.
Yeah, no. That sounds like a good follow-up study for someone to do.
Yeah. And by the way, I lied and went and got Novavax a couple of weeks ago. Told them I had never received a booster before because it had been 6 months since my bivalent. And I think 6 months seems like the right amount of time. In
theory, that's what we've been kind of thinking. Yeah, 6 months is probably every 6 months people should get boosted, although there's no guidance or U.S. guidance. In the UK, though, they're actually saying for people who are immunocompromised or severe, and same in Canada, they've actually recommended every 6 months. So the U.S. is not saying anything yet, unfortunately. But 6 months seems to be a nice time frame. as we know.
Yeah, unfortunately, you have to lie to do it. But if you go in and say that you don't have insurance, there's no way to look it up.
Right, right. This was an interesting paper that came out yesterday. So this was something I emailed a couple of folks, but not surprising, but I never had actually read this before, that SARS-CoV-2 can restructure your chromatin architecture, and this could be genetically changing you, and could be also chromatin restructuring is also a big thing in cancer, but they don't talk about cancer. I'm just bringing that conjecture here, indirect. But anyway, so basically, in this paper, they look at SARS-CoV-2 infection and how well, like in cells and tissue, might. This is like a figure from the paper, but this was an interesting figure that they looked at the chromatin compartmentalization, across different regions, and overall, like for example, these different regions here, they're showing definitely there's some restructuring happening in the chromatin in these different regions here, the H3K9, 4, and 27 mirrors. One interesting thing is that they saw that SARS-CoV-2 weakens chromatin contacts and cohesion loading in these different regions. It's also, they're comparing SARS-CoV-2 versus MOC and then different variations of this. And then one thing for the inflammation group, I know the paper we're getting ready there, they talk about how this chromatin restructuring actually impacts interferon and pro-inflammatory factors. So this is something that maybe the inflammation group might want to pay attention to. But this could also lead to a lot of different implications that I haven't even thought of. I think even more of their emails interactions. Earlier, so they talked about maybe mitochondrial implications of this and other implications related to the different regions, orphan and other regions, and how that might. I think Eve brought up the orphan genes. But yeah, so this is an interesting.
Hello.
Yeah. Oh, go ahead, Doug. Yeah. Oh, I thought Doug mentioned something. He was on mute. Okay. But yeah, I mean, I don't know if anyone has any insight in this or wants to comment, but it's an interesting paper people should read. They did a pretty comprehensive study on this. But yeah, just take a look.
Afshin,
go ahead, Doug.
That goes back to the Nature paper earlier this year that showed that ORF8 has motifs that look like they're involved in chromatin modifications.
Right. I forgot about that one. Yeah. And I guess the question is, how might this impact the mitochondria? Do you have any insight on that?
We've talked to Rob Schwartz about getting that expressed in cells so we could see. So we'll hopefully be able to talk more about that as we get some data.
Yeah, that'd be great.
Yeah, Doug, I was asking you on that line. I emailed you, but here you are. I was asking if you knew of, is there anything phenomena similar to that in mitochondria?
Say again, Eve. I didn't quite understand.
If there's anything similar to any kind of remodeling of the mitochondrial genome, not quite the
For
same.
other diseases, you're saying?
Any structural things that change in the mitochondrial genome?
By which you mean the mitochondrial DNA or the nuclear?
Yeah. The mitochondrial DNA.
We don't really know very much about the actual nucleoid structure of the mitochondrial DNA, except for that it's bound up with a single polypeptide that causes it to bend and to condense. But there are people who are looking at cis elements in the mitochondrial DNA that interact with nuclear trans elements, and they might be actually affecting its structure and transcription, but that's all very new.
Okay. Thanks.
Yeah. I guess we'll see how this plays out with the overall progression of or impact on health. According to them, it might be promoting inflammation in different types of interferon response. But I guess here's some good news for long COVID. I mean, if you want to consider long COVID bad news that we've heard over the past few months, but something that might not be so surprising. This study came out yesterday looking at Paxlovid and how it really does have an effect. These are like epidemiological studies that look at the larger patient population, and then they look across different COVID cohorts, and then look at, okay, yeah, it has a reduction or not. So no biology involved, but just purely, looking at the records and patient population. So indeed, they say here, that Paxlovid does reduce your chance of long COVID. Here's this massive study that came out yesterday too, but this is a huge UK study that they looked at. I forget how many now, but there was like maybe over 200 different studies. I forget how much it is now, but they looked at over about many different studies and thousands of patients that are going for post-COVID conditions, and then comparing people who developed long COVID and people who didn't. So one thing that I thought was nice, because these numbers for does vaccination actually reduce long COVID? That number's always been all over the place, right? That's been hard to pinpoint. We suspect it might, but in this study, they actually saw, from this big UK study that they saw that it does lower 42% risk from the study after your 2 doses for your long COVID. So that's actually very nice to hear. So another reason to get vaccinated and keep your boosters going. They don't talk about boosters. They just talk about the 2 doses. So I don't know after bivalent how much more it does or not, because this study doesn't encompass those patients yet in there. But then, who's most at risk for long COVID according to the study? Because they didn't just look about vaccination. They looked at BMI. They looked at everything under the sun, for patient population. So they said a woman, which is not surprising because we've heard that statistic over and over again, over 40, which I think we've heard that before, but not as frequently. And then people who are more obese, which had higher BMI content. Smokers, and this is not surprising. People who are immunosuppressed, obviously, we know that can be detrimental if you get COVID and then long COVID. The hospitalization, I think that's not a surprise to anyone. People who had more severe case and hospitalized with the acute phase, would, as we would suspect, have a higher chance to get long COVID. And then something that I didn't realize, diabetes definitely, and maybe asthma, COPD, but I didn't realize that people who did have like anxiety, depression before COVID had a high risk having it after for developing long COVID. But that's what and there are some other facts and tidbits in there about different things happening.
Do you think that could have to do with predisposition to the brain being inflamed?
I don't know, maybe, but I mean, there could be many different factors. But yeah, they don't talk about the biology, but that could be one possibility. But I don't know. Yeah, I don't think anyone's actually correlated why biologically before and after. If you have depression, anxiety, why would this be? I don't think I've seen this statistic before. I might have missed it, but I don't think I've seen people who are predisposed to anxiety, depression would have a higher chance of long COVID before this study.
Just a comment.
Yeah, go ahead.
It is there are several papers related mitochondrial dysfunction with anxiety and depression.
Yeah.
So it can be that probably if you have depression, anxiety, or something like that, it means that you have a mitochondrial vulnerability that can be very bad if you get COVID after, as we know.
Yeah. No, I mean, as we've hypothesized and I've been trying to think about, long COVID is, as Doug would say, long COVID is a mitochondrial disease, and a lot of the ones that got hit hard, as we know, had a predisposition for mitochondrial dysfunction prior to it, and I forgot the link between depression and anxiety, Chris. That's a really good point.
Yeah, and
some Sorry, go ahead.
I was just going to say, we find in our mouse models with mild mitochondrial dysfunction, you get neuropsychiatric symptoms.
Awesome.
Yeah, those are really good points. So maybe the true risk that these guys don't study, because they weren't looking at the molecular level of it, this should all be replaced by mitochondrial dysfunction. Hopefully we'll get. Yeah, what's that, Doug?
You finally got it.
Yeah. Yeah.
Do you think that this would also explain or maybe hint at why more women are being affected?
Related with mitochondrial dysfunction, you're saying?
Well, mitochondrials, like just It's like I don't know. I'm just asking a question. I don't know. Are women more predisposed to those sorts of
Don't
neuropsych
know. I guess
issues?
the person that would be
I
able to
don't know.
answer that would be Doug. I don't know those
Doug?
statistics.
We're having there's clear gender differences, and in the neuropsychiatric realm and on the mice where we have tested known mitochondrial defects, male mice versus female mice, we see that different neuropsychiatric presentations are biased toward one gender or the other. But that's as much as I know about it. So why this long COVID would be specific for women, I don't think we have enough data yet.
Okay. I just this is completely anecdotal, but I do see a lot of female long COVID patients who had some sort of neuropsych issues beforehand.
Yeah, I mean, this is
again totally observational, not scientific at all.
Sure.
And women are also prone to more autoimmune diseases, correct? So
absolutely, yeah.
Yeah, so that might be also a factor.
That's definitely, yeah.
This might be a good study for the N3C group to mine that data, the EHR data that's there, and see exactly what you mentioned, Diana, and others.
Well, the NIH EHR data is available to anyone who wants to use it.
Well, I know the N3C group has looked at many different things. People that like Justin and Peter's group, Peter Robinson's group, have done a lot of great work. But I guess I know Hannah's here from Peter's group. Maybe this is something, I don't know if you guys actually looked at, Hannah, look at it. Predispositions for like women who have been previously have neuropsych conditions, and then see how that relates. I don't know, Hannah, if you guys actually.
I sit on the publications committee for NIH Recover. I'll help get it through.
Right. Hey, Hannah, you're muted. I don't know if you wanted to mention anything.
It would help if I turned on my mic. And maybe turn off my video. A member of our group looked at neurological and behavioral symptoms that occur post-COVID, but I think he deliberately excluded from the cohort people who were diagnosed previously because he wanted to see the effect. We were trying to isolate the effect of COVID itself and not, study pre-existing conditions. So I don't think that would necessarily shed light on this question.
Right.
I mean, it's part of the long COVID. Neurological symptoms are part of the long COVID clustering that Justin presented, but they were only one part. It was not focused on that aspect specifically.
Yeah.
So the short answer is we don't have anything that's right on point for this question, but we've done research that's around the edges of it.
Sure. Yeah.
It's just that it's hard to. Most of the time, we're trying to distinguish between pre-existing conditions and COVID-induced conditions.
Right.
So it's not always easy to study the continuum between the pre and the post. Although now that I say that, there is someone, he's not a member of our group, but there's a different clustering approach that's been applied to N3C data, which is it's applying topic modeling to patient records. So, in other words, and this work has been done in a time-sensitive manner. So you identify the dominant, we can consider them topics, but you could also call them clusters. You identify the dominant topics that a person experienced pre-infection, and then look at where they wind up with respect to the same topics, but post-infection, and then look at what you're actually trying to study is the trajectory between pre and post, and how does the mix of topics change for an individual patient as they go through an experience of COVID infection. So there has been work like that, but I'm not the right person to tell you more because it was outside of Peter Robinson's group.
I see. No. Well, I guess we might see someone publish that, but yeah, interesting. Yeah. I was wondering if you guys or anyone else have looked at that. But yeah, it's a tougher question to answer, definitely, when you mine the data and play with it. Yeah. Thanks, Hannah. Okay. So I guess this is the long COVID news I have. I'm sure there's stuff I've missed, but I guess we could always come back to it next week or, so this I'll skip, but yeah, so then not much changes in the variant distribution, as we all know. I mean, there is plenty of other XBBs that are popping up, as we see here in this chart here. You can see all the different XBBs that are popping up, but nothing's out competing the main one, .1, .5, and that one's pretty much dominant form all over the U.S. and a lot of places around the world. So the wastewater in the U.S. Again is showing that steady decline. There's a little plateau here that's starting to flatten, but that could just be, next week it still could keep going down because you see the little bumps happening here. And Middlesex County, where I'm at, I just showed that one. Again, there's, you have these ups and downs, but it's still going down. So wastewater, I think, since the actual testing is not very reliable these days to actually show what's the positivity rate in the community. I think wastewater is probably the best alternative to that to show this, since it doesn't rely on people reporting it. And again, the wastewater shows, as you see, pretty much in the U.S. and the wastewater, XBB is the most dominant one taken over, and nothing's out competing it yet. So that's just a good thing, I think. Again, the U.S. variants, the CDC tracker, and as you see here, XBB now, as we saw over the past few weeks, months, it was the East Coast, and then XBB, that 1.5, pretty much is taking over the West Coast too, across the U.S. But globally, just the trends are pretty much the same everywhere. What we see here, just the more macro scale cases, again, reporting everywhere is not as reliable as we know, since a lot of places don't have trackers anymore set up or have been discontinuing that. But hospitalizations or ICUs might be a good indication, which show that these are on the decline and keep going down. Deaths might not be as a good way to track either, as I keep saying, because thankfully, due to our newer treatments and vaccinations, deaths have been greatly reduced across the board since the beginning. Now going to individual countries, France, again, cases, but you see that patient ICUs and hospital admission are a little bit going up, but this could just be a little blip, but it's kind of plateaued there. Germany seems to have an uptake in ICU, but when you do a search on COVID in Germany, there's no news saying there's actually anything happening. So again, you see these little blips going up and down. Maybe it's just patterns that there'll be more people getting infected than non-infected. But I mean, the overall trend, the hospital admissions are down. U.S. we already went over. South American countries and Brazil, I mean, again, steadily down. No new cases, but again, lack of testing and lack of testing or lack of reporting, I should say, of testing. But the deaths are down. In Japan, which had this huge spike when the last variant of Omicron hit them, is now pretty much cases, patient ICU deaths have been going down steadily. So that's all I have to report today. I'm not sure if anyone has any comments or anything I missed, but